I'm Bob Pryor, and today I'm talking to you about sine and cosine in the unit circle. These new definitions are related to, but different than the definitions we've seen before for sine and cosine. Let me first of all pick an arbitrary point xy and draw the radius as you see with the angle theta. Of course, we know that radius is 1, and what we can do at this point is draw a right triangle there in quadrant 1 by dropping a line straight down to the x-axis. This forms, of course, two sides. One side is x along the x-axis and the other side is y. Now we can use those values to develop the sine of theta and cosine of theta in the unit circle. Notice the sine of theta opposite over hypotenuse is y over 1, which is just y. And cosine being adjacent over hypotenuse simplifies to just x. That's actually the new definitions for sine and cosine. They are in the unit circle. In fact, we can write the x and y coordinates this way. Cosine of theta, again for x, comma, sine of theta for y. It's kind of alphabetical. You know how x and y are alphabetical? Well, cosine and sine are alphabetical. So that might help you remember which is which. So let's go ahead and apply this to a very particular angle measure, sine of, or 30 degrees, and we'll find the sine of 30 and the cosine of 30 degrees. We've already learned that the point at 30 degrees is radical 3 over 2 comma 1/2. Those are the x and y values. And because, as we've just learned, cosine of theta is equal to the x value and sine theta is equal to the y value in a unit circle, that is, in a unit circle. That means then that the cosine of 30 degrees is this x value square root of 3 over 2. And the sine of 30 degrees is the sine value, the y value, 1/2. Let's apply this around the unit circle in other quadrants. We can see here that we have all 4 related angles together that are theta hat equals 30 degrees. And you can see the ordered pairs that are already there. You can see how in quadrant 1 they're both positive, and in quadrant 2 the x is negative and the y is positive. Quadrant 3 they're both negative. So to find the sine of 150 degrees, we simply look at the y value at 150 degrees on the unit circle. We see that it's 1/2, so therefore the sine of 150 degrees is 1/2. Likewise, cosine of 150 degrees is the x value at cosine, or at 150, and so that's negative square root of 3 over 2. For sine of 210 degrees, we look at the y value at 210, which is negative 1/2. And for cosine of 330 degrees, I circled the wrong one up there. I circled 210, but at 330 degrees, cosine is positive. It's a positive x square root of 3 over 2. Okay, let's put that into action with other values that actually have theta hat equals 30 degrees. So we're looking at cosine of 390 degrees. We have 510 degrees, negative 150, and negative 210. We kind of need to know where these are located in the unit circle. So when 390 is more than 360s, we'll subtract 360 to find the coterminal angle. And of course, it occurs at 30 degrees. We'll do the same for 510 degrees. Subtract 360 and we get 150 degrees. And we'll look at that point in a moment. For sine of negative 150 degrees, we need to go, of course, in the negative direction. We could add 360 to that. It's at the same location as actually positive 210 degrees. And negative 210 degrees, its location is actually at the same location as positive 150. They are coterminal. So now that we have those values there, I want you to recognize that they are all theta hat equals 30 degrees. They're all related to each other at 30 degrees. And the ordered pair at 30 degrees is square root of 3 over 2, comma, 1/2. There it is. The thing is, we don't need to write it all the way around the circle. We can just use the positive and negative in each quadrant to relate it back to the individual cosine and sine values for theta hat equals 30 degrees. For example, at 390 degrees in quadrant 1, the cosine value is the x value, square root of 3 over 2. In 510 degrees, the sine value is the y value in quadrant 2, which is positive. Y is positive in quadrant 2, so it's the positive 1/2. And in quadrant 3, where sine of negative 150 is, it's a negative 1/2 because sine is negative. Likewise, in quadrant 2 at negative 210 degrees, cosine is negative square root of 3 over 2. Did you notice the positive I emphasized with a plus sign? All right, let's kind of do the same thing now for theta hat equals 60 degrees. We'll locate the individual degree measures first that are related to 60 degrees. You see 120, 240, and 300 in quadrant 4. And then we're going to go ahead and write in the ordered pairs. As we saw in the previous example, we don't really need to write the ordered pairs in for all 4 quadrants. Knowing quadrant 1 is sufficient. But here we go. Okay, let's go ahead and find sine of 60 degrees. We look at the location of 60 degrees and see the y value for sine, and that's radical 3 over 2. The cosine of 60 degrees is 1/2. It's the x value, 1/2. In a sine of 240 degrees, we look at quadrant 3, and it's a sine, so we're looking at the y value, which is negative, and it's a negative square root of 3 over 2. And for cosine of 300 degrees, we look in quadrant 4. We see that x is positive and x is the cosine, so cosine of 300 degrees is 1/2. Let's do this now for other angle measures that have theta hat equals 60 degrees. Okay, some of these angle measures are more than 360 and some of them are negative. So let's go ahead and find their locations first of all. 480 degrees is more than 360, so we'll go ahead and subtract 360 from that. And that is 120 degrees. So let's see, that's in quadrant 2. We'll get there in a moment. 660, we'll subtract 360 to get 300 degrees, a 4th quadrant value. And for negative 240, we'll actually add 360 to get a positive 120 again. So those are all coterminal. And we'll do the same for negative 300 degrees, add 360, and we get 60 degrees. Now, because they're all related to 60 degrees, we don't need to actually have the points shown all throughout. We don't need to put the ordered pairs. We can just recognize where the points are. Here we have 120 and 300 degrees in their respective quadrants, and 60 degrees too. But all we need for the ordered pair is just the quadrant 1 ordered pair. It's just the positivity and negativity in each quadrant that makes the difference at this point. So cosine of 480 degrees, let's see, that's at 120. Cosine's negative there. Let's identify the fact that it's negative first, and then look at the value of 1/2 for x. And of course, sine of 660 degrees, quadrant 4, so sine is negative there, and it's the negative y value of radical 3 over 2. Sine, again, y value, this time negative 240 degrees, which is coterminal with 120 in quadrant 2, so sine is positive. And cosine is positive for negative 300 degrees, and notice I'm using the plus sign here to emphasize that they're positive. Let's do the same thing for 45 degrees. I want to show you something about these numbers. Of course, they're related to 45 degrees, but they all end in 5. But not all angle measures that end in 5 are related to 45 degrees. And here's something interesting. If we take the 135 and take the 1 and the 3 and we add them together, 1 plus 3 is 4. Kind of like 45 degrees. And if we took the 225 degree measure and we add the 22, or the 2 and 2 together, 2 plus 2, of course, is 4. Again, 45 degrees. This is a way that you can tell if an angle is related to 45 degrees or not. Kind of interesting. Even at 315 degrees, we add the 3 and the 1. 3 plus 1, of course, is 4. Again, 45 degrees is what it's equivalent to, or the theta hat value. Now you might be wondering, well, what about if we go beyond 1 revolution? Well, take a look at 225 degrees. It is coterminal with 585 degrees. And if we add the 5 and 8 together, 5 plus 8 is 13. Well, that doesn't add up to 4. Well, no, it doesn't. However, the 13, the 1 plus 3, does add to 4. Ooh, I know. That's pretty exciting. Let me go ahead and erase all that because that's going to just get in the way of what we're supposed to be doing here. Okay, so let's go ahead and find the XY values around the unit circle that are all related to 45 degrees. Of course, it's the very same X and Y values. The only difference is positive or negative, depending upon the quadrant. So for this first set of exercises, we're going to focus just on values that are less than 360 degrees. Sine of 45 degrees, we look at the y value at 45, and it's square root of 2 over 2. Cosine of 135, we look at the x value at 135, and it is negative square root of 2 over 2. We look at the sine value in quadrant 3, that's the y value, 225 degrees. We're looking at negative square root of 2 over 2. And in quadrant 4 for cosine, it's positive. It's the x value, and we see that it's a positive square root of 2 over 2. Now let's apply this same principle to other angle measures that are related to 45 degrees. Some that are beyond 360, so we need to subtract 360 from it. We'll go ahead and find those values. Or if they are negative, we'll add 360. What we're trying to do with this, either subtracting or adding 360 degrees, is find the coterminal angles in measures that are more familiar to us, in the original 360 degrees, once around the unit circle. Let's go ahead and mark up each of those measures in the unit circle. So 45, 225 degrees in quadrant 3, 315 degrees in quadrant 4, and 135 degrees in quadrant 2. Now, like I said before, we need only one ordered pair to represent all of those that are related to 45 degrees. If we just find it for 45 degrees, the ordered pair of radical 2 over 2, comma, radical 2 over 2, and knowing the positivity and negativity in each quadrant, we can answer each of these questions. Sine of 405 degrees is exactly the same as sine of 45. Quadrant 1 is positive square root of 2 over 2. Cosine of 225 degrees, negative square root of 2 over 2 in quadrant 3. And cosine in quadrant 4 is positive, so positive square root of 2 over 2. And sine in quadrant 2 at 135 degrees is also positive, square root of 2 over 2. All right. Let's take a look now at the axial points, the angle measures there on the axes.
Yeah, that's the ticket.